Let's look at how to solve and graph systems of equations. So here we have a system of equations. A system is going to be two or more equations. 2x plus 3y equals 12 and 2x minus y equals 4. So the first way that we can find the solution of a system of equations is by graphing. Okay, I've created an x and y chart and I've selected three values for my x, and then what I've done is substituted that in for x to get my y. Okay, so we'll go ahead and just do this 0 together, and then we'll graph the line. Okay, so we're substituting 0 in for x. So we have 0 plus 3y equals 12. That's just going to become 3y equals 12. Okay, divide both sides by 3, and y equals 4. Okay, so I've just substituted negative 3 into the equation to get 6, and 3 into the equation to get 2. Alright, so now I have three ordered pairs that I can now graph. So we have negative 3, 6, 0, 4, and 3, 2. Okay, so first negative 3, 6, it's right here. Okay, this is the y-axis, this is the x-axis. So we're starting at the origin and either moving left or right and then up or down. Okay, 0, 4, so I'm staying right at 0 there and I'm going to go up 4. And then 3, 2. Okay, you'll want to at least graph, at least have 3 points on there to draw a decent line. Okay, let's look at the second equation, 2x minus y equals 4. Okay, so we're going to substitute negative 2 in, so 2 times negative 2 minus y equals 4. 2 times negative 2 is negative 4 minus y equals 4. Add 4 to both sides. Negative y equals 8. Okay, we don't want to leave it as negative y. We can think of that having a 1 in front of the y. That's really the coefficient there. So we're going to divide both sides by negative 1, and y equals negative 8. Alright, so we have our three ordered pairs, so now we can graph those. We have negative 2, negative 8, 0, negative 4, and 4, 4. Okay, so first negative 2, negative 8 is right here, 0, negative 4, and 4, 4. Now our solution is going to be where these two lines cross. Okay, so we're looking at where the two lines intersect. That would be considered our solution. So let's go ahead and draw the first line. Okay, and then the second line. Okay, and we'll go ahead and put a point at the intersection of the two lines. That is our solution. Okay, so our two lines intersect at 3, 2. Okay, 3, 2. So the solution of this system of equations is 3, 2. All right, let's look at the same set of equations. Okay, we have the same system here. We just want to look at how to find the solution a little bit differently. Okay, the first way was looking at by graphing the two equations and then just finding the point of intersection. Let's use a little algebra now to find the solution. So what you want to do is first make sure that all of the variables line up, and in this case, this one, everything's lining up. We want our x's in the same column and our y's in the same column. What we want to do is look at a way to cancel out either an x or a y. If we can cancel out an x or a y, then we can solve for one of the variables. So in this case, I have a 2x and a 2x. So if I were to multiply one of these by -1, then I could cancel out those 2's. So I'm going to go ahead and do that. So if we multiplied, and you can do either one, but we'll just go ahead and do this one here. So we're going to multiply this by -1, and we'll go ahead and multiply the right side of the equation by -1 as well. Okay, so we're going to rewrite both of these. So we'll keep the top one as in the same color there. So 2x plus 3y equals 12. And then we'll rewrite our new equation in orange. So 1 times 2x, or I'm sorry, -1 times 2x, -2x plus y. Okay, negative times a negative is a positive, equals -4. Okay, now these x's are going to cancel out. 2x minus 2x is 0. Okay, so we can rewrite these. 3y plus y is 4y equals 12 minus 4 is 8. All right, divide both sides by 4, and our y equals 2. Now that we've found our y, we can go ahead and substitute that into our original equation. So we'll go ahead and substitute it in this equation. So we have 2x plus 3 times 2 equals 12. So I'm substituting that 2 in for my y. Okay, 2x plus 6 equals 12. Subtract 6 from both sides. We have 2x equals 6. Divide both sides by 2, and x equals 3. So our solution is 3, 2. Okay. So solution we say the solution is 3, 2. So if we go back to our original example, you can see that we found that solution and it matches up. So all right, let's look at another one. Just looking at how to cancel out either an x or a y here by using the additive inverse. Okay, in this case, it looks like we have 13 and 5, so that really doesn't look very easy to cancel out. But we do have a 2 and a 4, so what we can do with this one is if we can bring this up to a 4y, then those y's will cancel out. Right, so let's go ahead and do that. So we're going to multiply both sides of this by 2. Both sides of the equation by 2. Which that's going to become 10x plus 4y equals 29 times 2 is 58. And then go ahead and rewrite the next equation. So we're just rewriting this top equation the same way it was. 13x minus 4y equals 57. And then we're going to just add the two equations together. Okay, so these are going to the y's are going to cancel out, and we have 23x equals. Add that, and you should get 115. Okay, divide both sides by 23, and x is going to equal 5. Okay, so I found my x. Now I'm just going to substitute that in to one of the equations. Okay, so I'm going to put 5 in for x. So 13 times 5 minus 4y equals 57. Okay, 13 times 5 is 65 minus 4y equals 57. Okay, subtract 65 from both sides. And we have negative 4y equals negative 8. Divide both sides by negative 4 and y equals 2. Negative 8 divided by negative 4. Okay, so now we have our x and y. And we can write this out. Just going to move this a little bit so there's some space to write. The solution of this system is 5, 2. Okay, 5, 2. We found our x, and then we found our y. All right, let's go ahead and look at one more. This one here, this systems of equations is not lined up, so we have to do a little bit of moving around to line up our x's and our y's. All right, so the first thing we want to do is get this, we already have an x and a y on the left side of this bottom equation, so let's go ahead and just move this x over to the other side of the equal sign. Okay, so if I add 4x, I can add that to both sides, and that moves it over. So we have 4x plus 2y equals negative 42. Okay, and our second equation just stays the same. So we have 4x plus 2y, or negative x plus 2y equals 23. All right, now they're lined up, so we want to cancel something out here. Well, the two y's are the same already, so if we just multiply this bottom equation by negative 1, we can have a situation where the y's will cancel out. Okay, so we're rewriting this 4x plus 2y equals negative 42. And this is going to become x. We have a negative times a negative, minus 2y equals negative 23. All right, combine 4x and x is 5x equals negative 65. Divide both sides by 5. X is going to equal negative 13. Okay, we can go ahead and substitute this back into one of our equations. So we have 4 times negative 13 plus 2y equals negative 42. Okay, negative 52 plus 2y equals negative 42. Okay, I'm going to add that to both sides. Add that 52. 2y equals 10. And y is going to equal 5. All right, so our solution for this system of equations is, our solution for this system of equations is going to be negative 13, 5. Negative 13, 5. And we'll just go ahead and write that out. Okay, remember that's where the two lines intersect. Okay, so that's what we're finding here. That's our solution. All right, thanks for watching. Email me if you have questions. Have a great day. Bye.